So 2.6, graphing absolute value functions. Up to this point, we've done a lot with linear functions. But a absolute value function, although it's related, and it kind of is related somewhat to the slope of lines and the intercepts of lines, it does have its own unique qualities about it. The first thing you need to know is that an absolute value function could be in the form f of x equals the absolute value of x, or y equals the absolute value of x. Okay. The shape, it is going to be a V. The reason it looks like that is because positives stay positive, so that would be that side of the V. But negatives, we have to multiply by a negative to flip it to a positive, so that's this side. See, that's a negative slope. So you end up with this V. So the main thing that will help us to graph these is finding the vertex of the V. So it is the switchover of or the point of the V. That is your vertex. And you always find it by taking the inside and setting it equal to 0. Okay, so our original absolute value function, these original functions here, those are called the parent functions of the absolute value. When you take either, if you take pre-calc next year or college algebra or algebra 3, I would, if I was teaching it to you, there's some techniques that you could graph these a little easier, but what I show you now will work for you even if you take a pre-calc class. And you kind of want to do the same procedure every time when you do these, and it would be very helpful to you. We want to take and find that vertex as kind of our first stop before we move anywhere else. So now let's actually look at an example. So in this example, it says find the vertex and graph each with a table of at least 3 points. So our first one is y equals the absolute value of x plus 1. So the first thing you want to find is the vertex. So all you do is take the inside and set it equal to 0. So in this case, what I mean by the inside is what's inside your absolute value. If there's things on the outside of the absolute value, you disregard it. Just what's on the inside of your absolute value. So in this case, it's just a very simple, nice equation. Where does x plus 1 equal 0? So if you solve that, you got to move the 1, right? So we needed to subtract 1, and so our answer is x equals negative 1. And then the third thing you need to make is your table. Or that's the second thing, I'm sorry. The second thing you need to do is make your table. So in the middle of our table, we want our vertex, so we definitely have to plug in negative 1. Now we're going to plug negative 1 into the function. We'll just substitute that in and use our rules of, please excuse my dear Aunt Sally and all that good stuff. We want to plug in something below it and something above it. So let me switch that. Let's go negative 2 and 0. So you want one value below it and one value above it. You want to make these equidistant away. So I usually count by ones. Unless there's a fraction there, like if our fraction has a denominator of like 2, I might count 2 away. If it has like a third in it, I might count by 3 away. But mostly one away is going to work for us. And then the third thing is and then we're going to graph it. But first, let's plug in our value. So let's start with negative 2. So if we plug in negative 2, we get y equals the absolute value of negative 2 plus 1, which is the absolute value of negative 1. Now remember, an absolute value is the positive version of the answer. So you don't make the pieces positive. It is the positive version of the final answer. So that's why this final answer then would become a 1. Now let's plug in negative 1. We should get The absolute value of negative 1 plus 1. The absolute value of 0 is still 0. And then lastly, we need to plug in 0. So we get the absolute value of 0 plus 1. The absolute value of a positive does nothing to it. It just stays positive because the goal of an absolute value is to make the thing that's inside positive. And so if it's positive, it's going to stay positive. And so you get 1. Now, a way to check your work. If you have chosen the correct vertex, the surrounding values should be at the same height. So if you chose wrong, or if this math doesn't come that they match, check your math. You did something wrong, okay? So the two equidistant values away from the vertex should have the same y value. If they don't, you did it wrong. So go back and check your work. Maybe you chose the wrong vertex. Maybe you just did a little something funky with your signs. Okay, and now we're ready to graph it. So go over to your graph paper. At -2, we are at 1. At -1, we are at 0. At 0, we are at 1. You want to follow whatever slope you were at to the right. This one has a +1 slope to the right of -1 and a -1 slope to the left of -1. So it became a V, just like I was telling you that's what your absolute value function should look like. So again, let's go over the 3 steps. Find your vertex by setting the inside equal to 0. Fill out a table with that vertex value, one above it, one below it. Graph those points, make a V, you got it, okay? Do we have any questions about example A? Yes?
Can you explain the same y value part from the chart?
Yes, okay, so let me say one more time. Because it's a shape of a V, once we find the vertex, to the left of it, we should be at the same height as the same distance to the right of it. Anywhere we choose, really. So like if we are 6 away to the right and 6 away to the left, we should be at the same height. So it's just a matter of, because of the shape of that V, that's a really good way to check that you have that vertex in the right spot, because that equidistant, kind of shape of that V will make it really nice, okay? Any other questions about example A? Okay, let's do it again. So remember, we're going to find the vertex, we're going to do a table, and then we're going to graph it. Okay, so those are our 3 steps every time. Okay, first to find the vertex, we're going to set what's inside and only what's inside equal to 0. That's 0. That's great. So our table, you're going to choose 0 as kind of the center of it. I think of it, it's the point of it. It's the center of my V. So then choose something to the left of that and something to the right of that. Many times just one away is good enough. That usually will work just fine. Now let's fill in our table. If x is -1, we get the absolute value of -1 plus 1. Now remember what that does. The absolute value makes that thing a positive. So when we add on 1, we get 2. Now if we did it right, it might be good to plug this one in. Let's plug that one in. If we plug in 1, we should get an answer of 2 if we did our math right. So it's the absolute value of 1 plus 1, which is indeed 2. So that's great. That really verifies what we were thinking, that our vertex is 0. So the last one we need to find is, what is that vertex? Where is the point at? So if I plug in 0, I get the absolute value of 0 plus 1. Well, the absolute value of positive stays the same. The absolute value of 0 stays the same. So that's 0. And anything plus 0 is itself, so that's just 1. And then another check for yourself is when we go to graph, that first 3 points that you plug in should make a V. And then you just have to connect it and make the V's arms go outward. So if I plug in -1 and go up to 2, 0 is at 1, 1 is at 2. what's interesting, it is related to the line y equals plus 1 for 1/2 and y equals negative x plus 1 for the other half. It is related to what we know about linear equations. Doesn't this have a y-intercept of 1 and goes up 1 over 1, up 1 over 1, up 1 over 1? And this one goes y-intercept of 1, and it would be a downward slope. So it is related. It's like half is a positive slope and half is a negative slope. Okay, any questions about B? Let's do another one. Same 3 steps. First, to find the vertex, we're going to set the inside, which is this chunk alone, equal to 0. Inside equals 0 is your first step to find that vertex. So we would add 4 to both sides to get 2x equals 4. And then we got to divide that 2 off, so we get x is equal to 2. So we know now on our table, put your vertex in the middle. Now, you can go 1 above it and below it. You go 2 above it and below it. It doesn't matter. If it's nice like this and there's no fractions I see, I usually go 1. So 1 below it is 1. 1 above it is 3. Remember, when I plug in 1 and 3, I should get the same value. When I plug in 1 and 3, I should get the same value. That's a way to check your work. So now let's go ahead and plug in and finish our table. So we're going to have to plug in 1, 2, and 3. We're just plugging that back into the original, following our rules of absolute values. This negative in front will make every single one of these values negative because this will be a positive, and that will be the opposite of it. And so everyone, we should expect to get a negative value. Let's practice. It would be the absolute value of 2 times 1, which is 2, minus 4, which is the absolute value of negative 2 with a negative in front. Now remember, this part is going to become a positive 2, but there's a negative in front. So that negative in front, these two don't cancel out. The absolute value becomes a positive 2, but the negative in front says, oh, I want the opposite of that. And that's why it makes it a negative 2. Now, if we did it right, 3 should do the same thing. Okay, let's do it. The absolute value of 6 minus 4, because 3 times 2 is 6. So if you want to do that multiplication in your head, you can do that. That's the opposite of the absolute value of 2, which is the opposite of 2. Hey, we got negative 2 again. So odds are we're good to go as far as choosing our vertex, correct? Let's find our vertex. Here is our vertex right here. If we plug in 2, what do we get? Okay. The opposite of 4 minus 4, which is the opposite of 0. And we set it equal to 0, right? And the opposite of 0 is just 0. So now let's go ahead and make our V. We should get a V shaped. Now let me kind of tell you what happens. This will be a little steeper because the 2 kind of makes our slopes 2 instead of 1. This actually moves it to the right a little bit, and this flips it upside down. So we're going to get a V now. If there's ever a negative on the outside of the absolute value, it will be flipped upside down. Okay, so let's verify that that's what happened. At 1, we are at negative 2. At 2, we're at 0. At 3, we're also at negative 2. And indeed, we have a little bit steeper of a slope on our lines. We have shifted over to the right. We have flipped upside down. So all of those things have transformed the graph in that way. Any questions about how we graph C? Good? Okay, one more. Everybody got C down. Okay, let's do D. Okay, so remember, we're going to set the inside and only the inside equal to 0 to find our vertex. Our vertex is going to be when x is negative 1. So usually that's a very nice equation to solve. You know, you just got to get that x by itself. It's usually a pretty nice equation. So we know our vertex happens at negative 1. 1 below that is negative 2. 1 above that is 0. So those would be the 3 values I would say are good to plug into your function. Negative 2, negative 1, and 0. So we're just substituting that into our function. Follow your order of operations. The absolute value makes it positive. The final answer. Okay, so we get 2 times the absolute value of negative 2 plus 1 minus 1. So that's our initial substitution. Take out the x, replace it with negative 2. Sometimes you might have to put a parenthesis there. You don't really have to for this one. 2 times the absolute value of negative 1. Because the absolute value will make this portion positive, that's just 2 times positive 1. And then that becomes 2 minus 1, or 1. Now, I expect if I did it right, that this will also give me a value of 1. But you should verify that. Don't assume it, because then it'll fix something that you may have got something wrong. Let's plug in 0 just to make sure. We get 2 times the absolute value of 1 minus 1, which is 2 times 1 minus 1, which is 2 minus 1, or 1. So it does come out to be 1, just as I predicted. Okay. So then the last value we need is at negative 1. We get 2 times the absolute value of 0 minus 1. 0 minus 1 is negative 1. So what happened to the function here? Well, this should move it to the left, and if you go into pre-calc or college algebra next year, you'll talk about why. But it's basically because you have to subtract the 1. This is actually going to drop our function down by 1. And this 2 here is going to make it a little steeper than normal. Okay. So let's go ahead and draw our graph. So at negative 2, I am at 1. At negative, my pencil needs to wake up. At negative 2, I'm at 1. At negative 1, I'm at negative 1. And at 0, I'm also at 1. You see how my 3 initial points are shaped in a V. So just follow that V outward and make it go to the right, go to the left, following that same kind of slope and pattern. You can see this one has a slope of positive 2 if you were to check. This one has a slope of negative 2. So it's because of the fact that at the 0 point, one side's going to need to be switched and one side is not. And so that's what happens for an absolute value. Okay. Do we have any questions about the examples here? Okay. Down below here is there are 12 problems. You're just please graph it and do the 3 steps for each of them like I had done in the examples, and then take a picture when you're done. If you need me for anything, just ask and we can go over any you need to, okay?